Okay, so here's the question. We have two spheres. The first is centered at the origin, has a uniform charge density rho and radius r0. The second has a uniform negative charge density minus rho. The center of the second sphere is shifted up from the center of the first sphere by an amount of d. And the question is, we need to show that the field in the region of overlap of the two spheres is constant and to find its value. Okay, let's go to the pattern. So here we have a scenario where we have two spheres. And let's put the second sphere here. Okay, and let's say this is centered here, the red one. And let's say that this green one is centered here. And so this distance here between them, or the vector between them, let's call it d. Okay, and this sphere here is the plus rho, and this sphere here is minus rho. Okay, so, and we need to prove that the field in this overlap region here is constant. Now, of course, in this overlap, there's going to be two fields, one due to the upper sphere and one is due to the lower sphere. So let's go ahead and find the one due to the lower sphere. Well, from Gauss's law, we can take a Gaussian surface here. Let's say like this, with a radius r, and let's call this let's call it r1, since this is lying in the positive one. Okay, and we know that EDA, Gauss's law says, so I'm going to use Gauss's law for this. Gauss's law. Okay, so Gauss's law says that EDA, so we're working, let's call this sphere number 1, and this here is sphere number 2. So I'm working in sphere number 1, so E1 dA1 equals Q enclosed over epsilon. Okay. Now, this is a uniformly charged sphere. It's a uniform charge density. So let's find what Q enclosed is. Integral of rho d tau over the volume of the sphere. And this will be rho. And d tau in spherical coordinates will give us, well, it's d theta, which gets you a 2. G phi, which from 0 to 2 pi, that gets you 2 pi. Sine theta, d theta from 0 to pi gets you a 2. And r squared gets you r cubed over 3. From 0 to r, so you get the same thing. So Q enclosed will equal to 4 over 3, which is the volume of the sphere, basically. 4 over 3 pi r cubed rho. And so, and this is R1, we said. Okay, so now I can plug it into Gauss's law. So Gauss's law says, so due to symmetry, I can pull E outside the integral, E1. dA1 is just the area of my Gaussian surface, which is a sphere, which is 4 pi R1 squared equals 4/3 pi R1 cubed rho over epsilon. And now if we do some simplification, we will get we will get this guy crosses the 3, 4 to the 4, the pi, so we get E1 to equal R1 rho over 3 epsilon. And this is, of course, in the R1 direction, unit vector. Okay, so this is my E1. Now, I could repeat and do the same exact thing on the second sphere. So let's not repeat the work. We just replace R1 with R2. We take a Gaussian surface here in the second sphere. And we call this radius R2. And so E2, so we replace rho with minus rho because the other sphere is negatively charged. So it will be minus rho this pad just closed on me. Give me a second. Open it. Get back to the pad in a second. Okay, I'm hoping that what I wrote syncs back, so I don't have to write over it. So might take a few moments for it. So now, yeah. So now for E2, I just replace R1 with R2. This is minus rho over 3 epsilon, and this is in the R2 direction. So now we basically have two vectors. So from the center of one sphere, I have, this is R1, giving me an electric field in that direction. So this is E1. And then from the center of the second sphere, I have another R2 giving me an E2. And this here is just D between them. Okay, and so my E will just be E1 plus E2 as vectors in the region of overlap, because there's two fields. So this will be rho over 3 epsilon. And then factor that out. So we have, well, I can combine these two into just R1 vector. Minus R2 vector. And you could see from the figure that R1 minus R2 is just D. So then I would have my E net is equal to rho over 3 epsilon in the d direction, and since d is constant, I have proved that this is a constant field in the overlapping region between the two spheres. That does it. Please don't forget to rate, subscribe, and comment if you want. Thanks.